All right, class, here is the review for the unit test. All right, question number 1. It says, which of the following questions could be used to analyze, could be best analyzed using a scatter plot? Okay, so for a scatter plot, remember that we need to have two variables, okay? Which we also call it a bivariate data, but just make sure to have two variables. Also, the variables have to be quantitative, meaning that they have to be represented by a number, okay? So let's take a look. It says how does the amount of time spent studying affect test scores? So you just have to ask yourself, does it have two things? Amount of time, yes, and test scores. And are they quantifiable? Yes, time is a number, and amount of time is our numbers, and test scores are numbers. Okay, well, that's it. That's the first one. The second one, I'll just go through them really quickly. Most popular color, that's not quantifiable. Average temperature, it's not bivariate, it's only one thing. How many students like chocolate or vanilla, that's not quantifiable. So A. All right, for number 2, a health scientist is interested in understanding the factors influencing heart disease. Which of the two following variables could be collected on? So since we're looking at heart disease, we want to find two variables because it has to be two variables. Let's see, favorite music, that's not quantifiable. I'm not going to pick that. Blood pressure, maybe. Cholesterol levels, maybe. Favorite food, that's not quantifiable, meaning that it's not represented by a number, right? Hours of TV watched, yes, that is quantifiable, but it has nothing to do with like heart disease. And maybe the weight. So I have 3 options to choose from. I think for heart disease, it's best if I use cholesterol and check their weight. Okay, or maybe cholesterol and blood pressure, but I'll go ahead and do, sorry, did I say weight? I meant it could be weight, but I think for heart disease, it's the blood pressure and cholesterol levels. Okay, so these two. You're going to make sure to pick two variables, make sure that they are quantifiable and that they are related to whatever we're interested in studying. Okay. All right, the next one for number 3. It says here, a city council is planning to improve public transportation services and wants to understand residents' commuting habits. They decide to randomly select 150 people. That's good that it's random, and it's good that it's 150 people. That's a good sample size. So these both look good. Who work in the downtown area to survey about their transportation preference. What is the disadvantage? So why is this something wrong? If it's random, it's good. It's 150 good. Then what is wrong with this sampling method? Well, let's check. It says random selection random is good. So this is fine. The survey might not only reflect the transportation preference of people who work downtown. Yes, it's this one. I'll tell you why. It's not sample size is too small. No, because the sample size of 150 is a good amount. Anything over 30 people is a good sample size, okay? Just for you to know. The survey might not be complete in the timely order. No, that's not it. I think it's okay to ask 150 people. The problem is that we're only looking at downtown area. We're not looking at something for the whole city, right? The city consists of downtown, suburbs, inner city. There's tons of different areas, not just downtown. So they really need to talk to people from all over the city. Okay. All right, so the next one, this is about linear regressions. Okay. So this is the next portion, linear regressions. Let me just quickly kind of go over where linear regression is. So now that you have a scatter plot, we're going to look at linear regression, which is a line that best fits your scatter plot. Okay. Remember, there's two things for a line. You have your slope, and then you have your y-intercept. Okay, if I have these two numbers, then I have my equation of a line. Okay, so it says here, Mrs. Rodriguez surveys the students in her chemistry class period. She compares the number of hours they studied for their most recent test and scores the exam. Okay, they should say exam. The maximum possible score is 100%. Okay. The results are shown below. So basically, this student studied for 0 hours and got a grade of like about 35% or so. This student studied for 1 hour and got this grade of 30 something. This student studied for 2 hours and got a 40%, and so on. So this student studied for 7 hours and got like a 90 something percent. And then one student did get 100%. Okay, use the data in the scatter plot to answer the questions below. If a student scores 90% on their test, so 90 is like right here, okay? How many hours did they likely study? So they probably studied about 7 hours, okay? So studied about 7 hours. Mrs. Rodriguez hopes to use this data to make further predictions about the student scores. But notice that the model will not be valid after 8 hours. So the model will not be valid after 8 hours. What does the data show to support this observation? Well, the reason is, looks like the trend went up and it keeps going up. And notice that the highest score that they can get is 100%. So even if they study more than 8 hours, the highest score is already achieved, okay? So the highest score is already achieved before 8 hours is what I would say. So I'm gonna go ahead and type it up, because the highest score is 100%, and it is already achieved. It is already achievable. Achievable after studying for 7 hours. 7 years, 7 hours. Okay. So it doesn't matter. So even if a student studies more than 8 hours, the highest score you can get is 100. So that there's no point in studying more than that. What could you conclude about the relationship between the hours studied and the test scores? Well, it seems like as the study hours increase, the test scores also increase. Okay. Right, so that's that. Number 7, which equation best represents the data below? So when you have a scatter plot, and you draw a line through it to best fit it. Actually, we use Desmos to do it, but in this case, I'll just go ahead and make a little prediction. We want to see which one of these equations looks best to that. So I'm going to go ahead and type each equation in Desmos and just check. So 2x plus 1. That doesn't look like the equation. Nope. Next one, it's negative 2x plus 1. That might be it. That looks pretty good. I would say it's B, but let me go ahead and check the rest of them as well. Y equals 1/2 x plus 1. Nope. Y. Nope. That's doesn't look like the same. And then the other one is negative x. So between these two lines, I would definitely go with the red one right here. This one looks like the best one that matches my line of best fit. Okay. All right. The data in the table below shows the average temperature in northern latitude Use the equation of the line of best fit to estimate the average temperature for a city with latitude of 48. Okay, so latitude of 48, latitude is in this column right here. A 48 is somewhere over here, right? Somewhere over here. 48 is somewhere over here. So we're looking for the y value. I have that data missing. So what I have to do is I have to do a linear regression. So I'm going to take my data and I'm going to put it in Desmos. So this is the steps, and this is what you should be able to do on the test tomorrow. Okay. I mean, not tomorrow, next week, or whenever you take it. All right. So I'm going to go ahead and add item by pressing the plus button. I'll go ahead and put a table of values. I'm going to plug in the table here. So I have 0. I'm going to put the x values here. 10, 20, 30, 40, 50. I'm not putting 48 because I don't have a y value for 48. So I'm just going to just put in the table as I have it and then put in my y value. All right, so I plugged in the data. I'm going to zoom out. So there is my scatter plot right there. Okay. All right. It says use the equation of the line of best fit. Okay, so to find the line of best fit, what I'm going to do is I'm going to press this regression, add regression, and then do a linear regression. Keep it like that. So here's the line of regression. And then here, I need to find where x is equal to 48. So what I can do here is I can copy the equation down right here, and then just go ahead and change the x value. I like to do that by putting a parentheses around the x, and then just deleting the x and then plugging in the value that I'm looking for, which is at 48. Okay, so the value is at 41 degrees. 41 degrees temperature. Okay, so that's my answer. All right, next one. For number 9, compare the scatter plot below with the parent function y equals x. Okay, so for y equals x looks like this. Let me just graph it in Desmos. All right, so let me kind of graph it on here so you have it right here. So the y equals x is this graph right here. All right, so for that, oh, sorry. Let me just change the color so you can see a little better. Okay, so for and let me go ahead and draw a line that's best fit through my scatter plot. I'll use a different color here. Let me do like I don't know, the green color, and here's the line of best fit right there. Okay, so what is this is asking is how would the parent function be adjusted to more accurately model the scatter plot? So how can I change the one in blue to make it look like more like the one in red? So if I look at the slope, it needs to be more steeper, right? It needs to be more steeper. Let me put this back and then show you. Okay, it needs to be more steeper. It needs to go down more so that they have the same slope, meaning they have the same slopes, same shape. Okay, so it looks like my slope has to be steeper. Sorry, not steeper, less steep. Sorry, less steep, because steeper means it has to go up higher. And the y-intercept, so the y-intercept, so right here, this line has to be less steep, meaning it has to go down more, and then it has to move up more, right? And the y-intercept has to move up. So the y-intercept has to move up. Okay. Same thing here. So let me go ahead and compare the two. So my y equals x. Let me make it into the y equals x, which is just going from corner to corner like this. And then my line of best fit, let me make that line of best fit look like this. Okay, so what this question is asking is, how can I adjust this equation to make it look like the green one? Okay, so it looks like, first of all, my y-intercept has to move down, right? My y-intercept has to move down. Let me go ahead and write that. And then the slope of the parent function should be steeper, meaning it needs to go up more. So the slope has to be steeper. Okay, so what I'm going to do right now is I'm going to go ahead and put everything back and then just look at it and then make our conclusion. Okay, so this one, the blue line has to go down more and then like shift it and then shift it up. Here the blue line has to go up more and then shift it down. Okay, so that's what all this means. Okay. All right, number 10. The scatter plot below displays Carter's weight each week after he started his diet. Okay, so here is the graph and then the line. The line of best fit for the data is right here. Okay, so they already give it. So again, whenever you have the line of best fit, there's two numbers, right? You have your slope, the rate of change, and then you have your initial value, which is your y-intercept. Okay. All right, so it looks like the slope is negative. Okay, the slope here is negative, so that means that it's a decrease. Okay, it's a decrease by whatever that number is, a decrease of 162 pounds each week. Okay, that's what that is. All right, the last question. You kind of had a question like this on the quiz that you guys took for my class, so hopefully this will make a little bit more sense. It says, so we have these four representations. Which representation shows a business with the most expensive initial value? Okay, most expensive initial value. So here looks like the initial value is at 0. Here the initial value is at 10. So here it's at 0, here is at 10. Here the initial value, it looks like it's 10, but let's take a deeper look here. It's about 10. It's a little bit, I would say about 9 let's say 9.9 or something like that. And then here, so I have two numbers for a 5-ounce medium cup. That doesn't really represent, it's between these two. Phil charges $3, so he charges $3 plus the topping of 50 cents each for this helping. So this is the slope, and this right here is the y-intercept of 3. Okay. All right, so now let's go ahead and look at the question, see what it's asking us to find. So which one, so this one has about 9.9. So which one has the most expensive initial value? I would say Frank's Pizzeria. Okay. All right, and then is that the last one? I believe so it is. Yep. All right, guys, so that is the review. It's 11 questions. Thanks for watching. Bye.